Hello guys, welcome back. Now in this session we are going to discuss about variable transformation. So in that aspect we are going to discuss about what actually the variable transformation is and why it is required. And we will also learn about how to do variable transformation. So let's jump into the Jupyter notebook where we are doing the lab. So guys, what is variable transformation? So when we perform the data analysis, at that time sometime we require to transform our variable so that it will be used by predictive models. So what it means, let's understand with an example. If you look into our earlier plot which we have drawn over here, we have drawn this plot if you remember. So over here this is the distribution plot which we have drawn with the help of sns.distplot. This is actually the representation of the distribution of the variables, and where you will find that most of the variable is skewed, that is at the left side, that is a positive skewed. So what it means? It means that the mean and the median will be greater than the mode. So you must be asking that, can you be specific to this particular example? If I'm taking this example where we are having the variable that is greater living area, which is written as GR live area. If you read this plot, then this plot means the houses which is having near to the range of 1800 square feet, that is being sold more compared to the others. So guys, this skewed data is very problematic if we are using it in a regression model. As our regression model will be trained on such kind of skewed data, then it will give the bias result. So every time it predict that whichever house will be sold, and that is going to be falling into 1800 square feet range, and on the basis of that it will forecast the wrong price. Same is the case with other skewed value. Over here if you will see that the first floor SF, this is also skewed data, and this kind of skewed data brings us biasness within the model, and that becomes very problematic if we are training our predictive model on biased data. We will get wrong forecasting from the predictive model. So here the question is, what is the solution for this? So the answer is variable transformation. So here we need to do some transformation to these variable, and then we need to send these variable for further processing. Now let's proceed further and fix this skewness with the help of variable transformation. But prior to doing that, let's understand, with the help of visual representation we come to know that this data is skewed or this variable is skewed. But how do you come to know that our variable is skewed without the visual representation? Then to answer your question, there is a formula available. On the basis of that, you can calculate the skewness within the variable, and the formula is this one, where mean minus median multiplied by 3 divided by standard deviation. On the basis of this formula, if we are getting 0, so that means our data is normally distributed and there is no skewness. And apart from that, if we are getting the result with positive value, so that means it is positively skewed, and if we are getting the result in negative value, then that means it is negatively skewed. So you must be thinking that you need to apply this formula by creating some custom function. Then the good news is that we are having a package called SciPy which contains a stats module, and that module contains the skew method that we are going to use to do the calculation to identify the skewness within the variable, and that is our next exercise prior to variable transformation. So let's jump into the Jupyter notebook. So guys, you must have understand that in what scenario we can apply the variable transformation. Yes, you are absolutely right. Whenever we are having the skewness within our variable, on that time we can apply the variable transformation. Now the next question is, how do we can identify that we are having the skewness within our data? I have shown you the formula, and now I am going to create a function which will identify the skewness within the data or within the variable, and if there is any skewness within the variable, it will transform it. But prior to writing this function, I want to discuss about what kind of transformation we can perform. If I talk about variable transformation, in one of the earlier session I have discussed about log transformation. That also help us to remove the skewness from the variable. But over here I am going to discuss about some other kind of a transformation that is called Box-Cox transformation. That is one of the standard mechanism to do the variable transformation. If you want to learn about Box-Cox transformation, I would suggest that you should visit this site to get some theoretical aspect of the Box-Cox transformation. So this site you can use it, that is statistichowto.com, where it has explained all the theoretical thing about the Box-Cox transformation. But in a simple term, I can tell that with the help of this transformation mechanism, we can transform our skewed variable to the normally distributed variable. and the math which is working behind the scene for this particular transformation is this one. One good news is that to perform this box-cox transformation, we don't need to write the custom function, as we are going to use the SciPy library, and there is a module called a stats module that will offer us functions to perform the box-cox transformation. So let's jump into the Jupyter notebook to start writing the code. So the first step is I'm going to import some of the module from the SciPy. So over here I will specify from scipy.stats import skew. The next thing, I need to import the functions for box-cox transformation. So first I will import scipy.special import boxcox 1p. Next, there is another function I am going to import, that is scipy.stats import boxcox underscore normmax. These two methods we are going to use for boxcox transformation. Now we are done with the first step where we have imported the required library. Next we will proceed further and write the custom function. So the function which I am going to write it over here, that will perform two things. The first thing, it will identify the skewness within the variable, and if there is any skewness, then it will fix the skewness with the help of boxcox transformation. So let's write it. Here we will tell that def fix underscore skewness, and this will accept the data frame. Now we have defined the function. Now what we will write it over here. So over here we will write the code to select the numeric feature, or say numerical variable, which has the skewness. So let's write it. So over here I will create a variable called skewed underscore feat. This will store the skewed feature, and over here I will tell data frame, and I will select the numerical feature. Where do I get the numerical feature, selected numerical feature? If you remember, we have already created in one of the exercise, and if you come over here, we have already performed this exercise and we have selected the numerical variable that is stored within the numeric call. So let's use this one, and over here I will specify this numerical call. Now next I need to select those variable which is having skewness. So how I can select that? I need to write a apply method where I need to pass the lambda function, and over here I will tell lambda, this is an anonymous function, and here I will check for the skewness, and I will tell skew, this is the function within the stats model, and over here I will tell x, and then I will tell sort underscore values. It should be ascending equal to false, so that it will display in descending. So this line of code will give us all the skewed variable, but we want to select those feature which is greater than 0.5. So how we can do that? So let's look into that. That is, I am calling it as a high skewed variable, and we are going to store those feature in this variable, and I will tell skewed underscore fit, and over here I will specify the absolute value, and over here I will tell skewed underscore fit, and that is greater than 0.5. So this will return all the variables which is having skewness more than 0.5. Once it is being done, we need to get the index of those variable. So how we will get that? So we need to write over here skewed underscore features equal to high underscore skew dot index. So this will give me the name of all those variables which is having more than 0.5 skewness. So guys, we got all the skewed feature which is more than 0.5. So now let's fix it with the boxcox transformation. So how we will do that? We need to tell for fit in skewed underscore features, and over here we need to write the code like this. Df, the feature we are selecting over here, it is iterating each of the feature, and over here we will tell boxcox 1p and the data frame, and over here I need to pass the variable, and over here I will tell boxcox underscore normmax, and within that I'm going to specify df feature plus 1. So this will transform our variable and make it normally distributed. So let's execute it. Shift enter. Now let me draw the plot without fixing the skewness, so that you will get the difference. So over here I will specify SNS dist plot. I'm going to draw one of the variable, and over here I'm going to choose df. Let's check one variable over here. So I'm going to use, we will look it over here, this one, first floor SF. So let's take this example. Let's draw it separately, and over here I will specify first floor SF. Now let's run it, shift enter. Then you will find that it is having skewness. So now let's perform the transformation, and I'm going to use this fix skewness method over here, and I'm going to pass the entire data frame so that it will fix the skewness in each of the numerical data type. Do shift enter. We got error. We have some typo. Make sure that it should be features. Now do shift enter. We have another typo as well. It should be normax, so it should be normax. Sorry guys, sorry for that. Now let's select this one, shift enter. Now let's run this as well. So it is executing. We got some warning, but let's look into the plot whether it has resolved the skewness issue or not with the help of this transformation, box-cox transformation. So let's copy this line of code and paste it over here, run it again, shift enter, and then you will find that it has fixed our skewness issue and everything is normally distributed over here. Let's check other variable as well over here. If you will look into that, then you will find that we are having greater living area is also skewed. So take this variable and come it over here and copy this line and try to plot that as well. So let's write it over here. You will tell that great live area. Now let's plot it, shift enter. Then you will find that this also being transformed with the help of box-cox transformation, and with the help of that we have removed the skewness. And this is what I wanted to demonstrate you in this session. In the next session we are going to discuss about variable creation, and that is the last step in the workflow of the data exploration and the preparation. So on this note I am stopping over here. See you in the next session. Till then, bye bye, take care.